Well, thank you, sir. Good morning to everyone. Hi, my name is Rakesh Kumar Chaudhary, working as the CEO of ISR, an organization devoted for research and development works. Besides research, we provide training relevant to water and environment science. Today, we have invited our trainer, researcher Ishwar Joshi, who will present online training on hydrological data management using SQLite. Ishwar Joshi did Bachelor in Civil Engineering from IIT Pulsar campus and then Master in Water Resources Engineering from Hohai University, China. He worked as a project engineer at Hydro Lab. He was mainly responsible for conducting physical hydraulic modeling of headworks of hydropower projects, numerical modeling using Flow 3D. He has also worked at NTNU for 1 year and then moved to Utah State University for PhD. Currently, he is working as a PhD student at Utah State University in Water Resources Engineering. Uh, Now, I would like to welcome Ishwar Joshi. Uh, Welcome, sir.
Yeah, can you hear me?
Yeah. It is.
Yeah,
Is it
thank you very much
audible?
to Rakesh sir for such a nice introduction. And also I'm grateful to Dynamic Solution and IHR team for conducting this training. So I want to share my screen, okay?
Okay.
So can you find my screen?
Yeah, it is visible.
Visible?
Yeah.
Okay. So hello everybody to the participants of this course, and thank you that you joined for this course, and it's a really important course for water resource researchers and also to the consultants in water resources. So me myself, Ishwar Joshi, as already introduced, I work as a PhD student at Utah State University. And in this first day, we'll introduce this course, or what this course is and what we'll learn from this course. So these are the outline of my first day lecture. So I'll briefly describe about how the hydrological data, what kind of data are monitored by different institutions in their countries and others. And similarly, then I'll describe about the need of the course, so why this course is important. And then the training outline, since we have 10 days of training classes, so I'll be describing in short about each day, so that like if the participants are interested, they can do their own research in the meantime to learn more from this course. So about going to the hydrological data, in every country, generally rivers or lakes are monitored, and generally the data collected are discharge and precipitation, river water level, and if data to be monitored is for the pond, then we collect temperature, humidity, wind speed for the evaporation in the pond. So these data are just representative here. We have a lot of hydrological data that we collect in rivers and ponds. So while collecting, generally institutions like in Nepal and the Department of Hydrology and Meteorology, and in US, the United States Geological Survey, they build the stations. Like for DISA, they build the gauging stations, and for precipitation, they build the meteorological stations and others. So to the participants, like, don't get confused, because here I'll describe station as gauging stations, which will incorporate both hydrological station as well as meteorological station. Because when I was studying a course in hydroinformatics here in US, every station is named just as gauging station. And in Nepal, only discharge is measured in the gauging station. So this is quite a difference here in the US and in other countries. So if the station here, it will be both hydro gauging station as well as will contain the meteorological data also. So this is about bit about the data. So practitioner will know what that data to collect, but here we'll learn how to collect data and how to manage them so that it's useful for them in research or in consulting practices. So in the need of the course, so why we is a problem. So in the need of the course, so why we to manage the hydrological data and why it is important. So if you consider US, there are 13,000 gauging stations. So it means both hydrological and meteorological stations. Okay. And these stations are monitored by USGS, United States Geological Survey, and all of the data are available through web services through USGS NWIS. And since if you want to build a climate model or a hydrological model such as SWOT, HMS, and then you need to have a well-managed data with you. So imagine like you are using a web service and you collect data for each station that has like years of data, maybe 30 years, 40 years. And you download data from that web service and then manipulate it and then use for the hydrological and climate models. So imagine like in climate model, if you want to use like 10,000 station data, so what you will do in that case? So it's a really challenging for us, and it's very time consuming for us also. So what do you think like US has done for that? So this is the thing that I'll teach in this course. So US has a lot of good research and it's very its research is always in the state of the art. So they have uh, tried to manage all these data in a very organized way, so that like practitioner in US can easily download those data, and it's using simple codes in Python and then manage it properly. So in the context of Nepal, as in Nepal, DHM, Department of Hydrology and Meteorology, it collects the data. And as I described in previous slide, like in US, like now you can download easily using simple Python code and then manage data in US. But in Nepal, if you go, it's a very cumbersome process. Me myself has personally experienced this. Then first of all, if you want to have data for a station, we need to first give them a phone call sometime, then fill the different forms, and then have to make the payment through bank, and then they finally send you data in a text file in your email. And it's a very, very cumbersome process. And imagine if you want to build a climate model and you do that for all of the data in the station. So it's quite cumbersome and it's very inefficient process. So this is the like to have like, oh, what is the situation in Nepal? As you can see that I wrote an email to them, to DHM first. Okay, sir, I want this data at this station. And they replied, okay, we have data at this station and these timesheet data are available. Then I have to again ask for the cost because it requires some amount of money to get the data. and they provided me this Excel spreadsheet where they put the cost as like 31,200 to get those data. And then after 1 week, they send me this data. This is just a sample, and it's a TXT file. Just after 1 week. And imagine like you want to use this data for hundreds of stations, thousands of stations, and you have all these text files. So imagine how cumbersome it will be. So, and also think like if you just write a 5-line code to retrieve all the data in a specific format, and that is well managed in a database, okay? And that then database can be easily sliced, diced, or edited as per the user need. And then this is actually possible using these two programming languages, Python and the SQLite. If you want to have a look, you can go to the LinkedIn, this website. I'll provide later. A researcher has used Python and SQLite to post-process the data that is obtained from simulation of SWOT. And if you don't use these two programming language, it's very, very time consuming, and it's just repetitive work for you. So going through this in the need of the course, so what do you think that how it will affect the water researcher and consultants in water resource? It will definitely save a hell lot of time. So I think that's why I thought this course is very important for researchers and water consultant, and especially to the researcher. We want to build big models like the climate models or the hydrological models, where hydrological data is really important and it's really time consuming to process them so that they can be used in the models. So these are the outline of the day 10 courses. So in the day 1, this is the introduction. Today we are doing that, and it'll be describe about these all in the subsequent slides. In day 2, we'll learn a bit about SQLite, what is SQLite, and then day 3 we'll work on SQLite, and day 4 we'll introduce Python, day 5 coding in Python, and day 6 we'll learn about how to retrieve hydrological data that we have in Excel file, and day 7 we'll describe about USGS data retrieval, and in day 8 we'll integrate SQLite and Python to retrieve hydrological data from USGS NWS website. And then in day 9 we'll describe a project. Since the day is only 10, we will not be able to do the project in this time period, but I will describe a project, and at day 10 we'll conclude the training. So in the day 2, I will describe about what is SQLite. Actually, SQLite is a programming language, very basic programming language, and it's very easy also. And it's open source and used by different hydrological models and numerical models like SWOT, HEC-RAS, and Basement. And you can download this SQLite through this website. We'll also do, we'll go through the training. And this is a database that I have taken a screenshot of, and you can see how the data is well managed here, and every details of data has been given, has been provided here, and like these are the discharge values of a station, and when the data was collected, at what side it was, and all of this. So we'll learn about SQLite in day 2. And in day 3, we'll work more on SQLite. So how to program in SQLite, okay? Here in the left side, we have a database which have discharge value from 70 to 189 as cubic feet per second. And by writing a simple code here in SQLite, like select data value from database, where data value is greater than 100, we can just get the data of discharge that is greater than 100, just by writing a simple code. So this tool is really powerful. It's like if you want to do in Excel, this can be done in Excel also, but there can be a lot that can be done in SQLite, and we'll learn in day 3 about programming in SQLite. And in day 4, we'll go to introduction to Python. What is Python? Python is a programming language, object-oriented programming language, and it's an open source. One good thing about it is it's freely available. It's very important to water resource engineering. And here in day 4, we'll introduce more about Python and how to do coding in Python so that we can retrieve data from different web services. We will use PyCharm to write code to write Python codes, and you can download PyCharm and Python through these websites I have provided, and also I will give more detail in day 4 about it. So how to download it and how to write simple codes in Python. So coding in Python in day 5, we'll write some codes so that we can download data from web services. So here we will download data from only USGS NWIS website, okay? In Nepal, we don't have that code developed so that we can easily download all the required hydrological data from DHM, and then that can be in the Python pandas data format. So we'll work more on this in day 5 for the USGS data. So it is important to know to the participant is that if you like could develop a a data retrieval code for Nepal, that will be very useful tool for other researcher and consultant practitioners in Nepal. It will be really good tool. You will see like how efficient this tool is. Just you need to have like station code and start time and the end time where the data is collected to retrieve the data. And just in 2 seconds you can have the data required. So we'll learn about this. And also learn like how to retrieve data from Excel. So if you have like data in Excel format or TXT format, we'll write codes so that we can import those data into pandas data format, so that we can further analyze this data. Okay, in day 6 we'll do that. And in day 7, as I already told, we'll work on how to retrieve data from USGS NWIS. So this, if you go to USGS website and want to download a data for a station, so a station is marked here in a river, and the web services shows data like this. They have real-time data. So we'll learn how to download this data in pandas data format, and then export it to SQLite database, and just read that data using the Python codes. Okay, in day 7 we will do that. And in day 8 we will learn how to integrate SQLite and Python. And is really important for us, and this learning will help to make our course interesting, and this will be actually the outcome of this course. And learning integrating SQLite and Python will help in automation of data retrieval and visualization. So imagine, like, I give you an example. If you want to get data, hydrological data for all of the station in Nepal, you just write a code and just you can visualize all of the data at once. So this is possible. Right now, what you have to do is you have to go to the web service in DHM website, and then you have to locate each station, and then after locating each station, you have to have a look at the respective data values like discharge or velocity or something like that. So with this, if we could could develop a system like this, just have a code and just click it and just visualize the data. I'll show you here as I did in my project. So here you can see, this is the code for data retrieval for Great Salt Lake. I'll not go in detail today, and we'll learn it later. So what it does is it connects the SQLite database here initially, and then it imports it writes the metadata into the SQLite database here, like the station number and the station name, and like what site ID it is, and like others. Now here we provide the site code for the respective station and provide the data, start date and end date. So these you can see. I didn't go in detail, just shown the code today. Okay. And then we have okay. Then we again write the SQLite statement to import the data from the database. I didn't go in much detail today. Okay. Just a code. And this code writes the figures after importing the data from USGS website, then exporting it to SQLite database, then again importing data from SQLite database, and then as I did click here, and it takes some times to retrieve data, write data, and read data, and at 5 this time. So now finally we have the data from the USGS website, just with one click. Like you can see, these are the hydrological data. It's a discharge data at different stations. Like you can see here that a beer level, you can see at the Weber River, these are the water level data in the pond. And these are the precipitation, temperature, and wind speed data. And this is the precipitation data. So with just one click, you can have all the observation. And we also have a solid database here, as you can see, flood research code.SQLite. So you have the visualization, you have the database also. And we will learn all about this. This is just a very short introduction today about this course. And more important thing about this is it's very flexible and it's reproducible also. So if you want to tame the code as you require, you can just edit this code and make it as you suit. And it's very easy. So you have to learn know know the information on SQLite and Python. So in day 9 I'll describe about a project that I did in one of my courses. So we cannot do a project here since it's just a training, but I'll describe how I did it and what result I got, and in terms of time saving and efficiency, how good it was. And is the code is reproducible or not for other research? We'll describe about that in this project. And in day 10, I'd like to have feedbacks from you participants so that we can improve more on this training, and also we'll have a discussion like if it is possible to use for the Nepalese context, and if we could develop this code for Nepal, and it will be really useful. So this is the end of day 1. I just give you a overview of the course. So if you have any questions, you can just put now. You can raise your hand, and I will be happy to discuss on that. If not, I'll finish this training. Yeah.
Okay, sir. Is there any question from the audience regarding the courses?